My name is Jun, and I'm a chemist who's very passionate about the environment. So I'm wrapping up my master's this year, and during the Wattle Fellowship, I decided to address the plastic waste crisis and climate change at the same time. How did I do it? Through the lens of green chemistry and education. It's a mouthful of topics, so let's dive in straight away. So let me start with the word chemicals. So what kind of emotions or thoughts do you have related to that word? It's not necessarily positive, is it? All right. And you can see what Google's telling you as well, some cherry-picked images with negativity here. Chemicals historically cause irreversible damage to us and the environment. Not in all cases, but majority. And there is this rising field known as green chemistry in response to that, which is all about sustainability. So how do we use chemicals that's not toxic? How do we use chemicals that's biodegradable, biorenewable, not made from fossil fuels? So Google this for the 12 principles of green chemistry. But the question here is, how is that related to plastic waste or climate change? Let me first start by addressing the plastic waste issue and recycling. So when we put plastics that we've used, the single-use ones, like the ones I have over here, you put it in the yellow curbside bin and hope for the best, right? But statistically, more than 80% of plastics have not been recycled in Australia. Correct me if I'm wrong. That's because, in my opinion, the key reason is the cost of recycling. The cost of recycling versus the cost of making new plastics from fossil fuel byproducts. It's still much cheaper, right? There's the effort needed to recycle. So how did I address this issue? I addressed this issue by looking at this plastic waste as an asset, right? As looking at this asset using green chemicals, for example, the ones I have here, made from sawdust. They can be found in lollies in your drinks. So for any brave ones out here, I'll just put these down. Just come up to me for some tasting session. So, so with those green chemicals and with these wastes over here, I made this material known as microbeads. The value of these, so this is a zoomed in version of that, by the way, it's very small. The value here of this material is first magnetic, so there's a lot of application there. And secondly, you can use it to extract critical minerals. So I'm sure anyone passionate about climate change knows how important critical minerals are. So that's the whole idea that I've explored at Melbourne Uni, but there were some issues that I was facing. I manually collected these wastes over time, but I can't really do that along with research at the same time. So there's industries that do that for a living. And also, in order to make more of these material on the commercial level to make greater impact, I need to partner up with industry. And that's exactly what I did at Wattle, thanks to the lucrative deals from John and Lynn. I was able to quit my part-time job as a chemistry teacher last year, invested countless hours into research, more research, and just reached out to all the networking events, talked to people who's doing the recycling. I think I paid myself about $10 per hour for this. But I was able to successfully engage 2 recycling facilities funded by the likes of CEFC. So that was a really big deal for me, and this is an exciting work in progress. And that was the green chemistry lens. So for the education lens, we have an exciting project at Melbourne Uni, which is called On-Campus Recycling of 3D Print Waste. So when students try to print something, they fail, right? They're still learning. So you have these useless parts lying around. If you don't have recycling strategy or any bins in place, these will go into landfill. So what we did was we received the funding from Sustainability Victoria, thanks to Professor Kevin and Dr. Wen, who might be in this room with us today. I know Dan's over here, our engineer. And what we did was we put the bin at dedicated printing space at Parkview. We bought brand new recycling equipment with the funding. And we treated, so these are the wastes. And then once they go through the machine, they would look like this, right? They would have small size, easy to work with. And then we use another machine to turn them into something known as a spool of filament. So this is what you need to print something on a 3D printer. So I'm not adding new value in this project. What we're creating is a closed loop recycling model within Parkview. So we don't need to partner up with a recycling facility, right? We just have everything contained in Parkview. And using this model, we are actually educating postgraduate level engineering students. This is still happening during this semester. And we're also reaching out to high school students. On the 5th of June, we'll be participating at the Youth Climate Seminar to discuss recycling is not a hoax, and it's also how related to the climate change. Right? So that's the whole idea. So just to wrap up, I want to summarize the two parts of my action plan in terms of the opportunities and the help that I'm looking for. For the green chemistry, trying to get ambitious. So the whole idea, I've spent countless hours to, organize it around climate change. But I'm trying to commercialize it, collaborate it, even thinking of a startup. It's a big thing. So I'm still considering that. And the big idea for the startup is to establish a consultancy for the Australian manufacturing industry, where we would focus on climate and social impact when we're making something useful for the society. And secondly, for the education, we're trying to look for people who can scale up the recycling facility that we have at Parkville, so we can not just use it for education, but for actual recycling. And thank you. That's a QR code for my LinkedIn, and that's the email that you could just shoot anything to. All right, thanks.